Hello, in this video tutorial, we'll give a detailed description on the CloudSim toolkit and also demonstrate it by running an example. My name is Aparna. Let us first start with an introduction to the CloudSim and how to install it.
CloudSim is a toolkit or library from Cloud Labs for simulation of cloud computing resources. The official website for CloudSim is www.cloudbus.org/CloudSim. This website gives a brief introduction on what is CloudSim and its main features. Before we start with the features of CloudSim, let us first find out what CloudSim does not do. CloudSim does not support any actual software technology. It does not run any real applications, therefore we cannot run our project on CloudSim. CloudSim is a simulator, but it does not come with any UI and does not run our application. It's a library which is written in pure Java, so we will have to write actual Java code to use it. The main features of CloudSim are listed in this website here. It supports modeling and simulation of large-scale computing data centers. It supports modeling and simulation of energy-aware computational resources, support for user-defined policies, for allocation of hosts to virtual machines, and policies for allocation of host resources to virtual machines. Now this shows that CloudSim simulates cloud environment so that developers can concentrate on the main modeling and policy problems while ignoring the actual working of the cloud, and it also gives a performance evaluation for the models and policies. Now there is a paper on the architecture of CloudSim called CloudSim, a toolkit for modeling and simulation of cloud computing environments and evaluation of resource provisioning algorithms. Now this paper gives a detailed architecture of CloudSim, including the class diagram, sequence diagram and such. We can see that here. The architecture of CloudSim, the class diagram, and some sequence diagrams that shows the important features and activities on CloudSim. However, it does not give any details on how the simulation actually works, but it is a good start to learn to start using CloudSim. Now moving on to how to install and use CloudSim. There is no installation procedure for CloudSim. It is a package that we need to download and use it as a library in our project. You can find the page on Google Codes for CloudSim. Here there's an announcement that CloudSim has moved into GitHub, so we can also get the package for CloudSim from GitHub, or we can download it here. We'll download the latest version. Or we can also get it from the GitHub. You can download as zip here. Now once you have downloaded this package, you extract the files. Once we finished extracting the folder here, we'll use one of our IDEs to use CloudSim. Since CloudSim does not come with its own UI, it's always recommended to use one of the IDEs. So we are using Eclipse here, and basic knowledge of Eclipse is always helpful. So to start with, we'll create a new Java project. Call it CloudSim project. Uncheck the use default location, browse to your folder, and make sure that the JRE is at least 1.7, and then finish. On finishing, you will see the hierarchy of packages in the package explorer. Now CloudSim is ready to use. The source files are in the sources package. You can also run some of the examples here to see how the codes are actually written. You will have to add your codes like these to use the source code given in these packages, or you can also write your own models and policies as given here, similar to these. Now that we have downloaded CloudSim and opened it in the Eclipse IDE, let us discuss about the framework CloudSim provides for simulation. For that, let us consider a simple example provided in the package org.cloudbus.cloudsim.examples, and let us consider CloudSim example1.java. This is a simple example showing how to create a data center with one host and run one cloudlet on it. Since creating data center with hosts and running cloudlets on them is the basic thing that happens in all simulations, this will help us understand the entire simulator better. Here's an image, a diagram that will show the working of the simulator. The first entity to be created is the Cloud Information Service, or the CIS. It is a registry where the entire resources available in cloud are registered, such as the data centers and its configurations and properties. Next, a data center is created. As soon as the data center is created, it is first registered with the CIS. A data center has one or more hosts. The example we have taken has one host in it. Also, the properties of the data center are listed in the data center characteristics class. A host has a number of VMs. In our example, the host has only one VM. Also, hosts have hardware configurations such as processing elements, which can be 1, 2, 3 and so on in number, RAM, which can be 512 MB, 1024 MB or 1 GB, 2 GB and so on, and a particular bandwidth. After the creation of CIS and the data center broker is created. The job of the broker is to submit tasks to the data center. In the initial stage, broker communicates with the CIS and retrieves resources information from the CIS, that is resources such as the data center characteristics. The tasks which are to be run are called cloudlets. Broker directly communicates with the data center and assigns cloudlets to the VMs in the hosts of the DC. Suppose there are two cloudlets, C1 and C2. C1 is assigned to VM1 and C2 is assigned to VM2 by the data center broker. All these components, CIS, data center broker and data center, are called entities in CloudSim, and they work on certain policies. Data center uses VM allocation policy to allocate VMs to the hosts. The hosts use VM scheduler policy for processing of VMs. Uh, VMs use cloudlet scheduler policy for processing of cloudlets. We have all these entities and their behaviors in terms of classes in various packages of the CloudSim. So until now we have understood the basic framework provided by CloudSim. Next we understand the package structure of the CloudSim to understand the simulation in a better way.
Hello, I'm Anushka. In this part of the video, we'll understand the package structure of CloudSim. Let us see what different packages within the CloudSim does. CloudSim provides around 12 packages, which we can see here. The first one is our OR CloudBus CloudSim. The classes within this package, once it is instantiated, it will behave like some component in the system, or it will support a specific component of the system for producing a relevant behavior during the simulation process. The classes within this package is classified into two categories. The first one being the simulating component classes. These set of classes imitate a particular part of the cloud setup. The classes which belong to this category are cloudlet, data center broker, file, host, then we have storage, PE, VM. These are some of the classes which belong to this category. The second category is the policy classes. These are set of classes that imitate the policy behavior of cloud setup. Now the classes which belong to this category are the utilization model, which has three other variations which we can see here. Then we have the allocation policy class, we have the scheduler class, and then last but not the least the cloud scheduler classes which belongs to this category. Now let us see what each class within this package does. So starting with cloudlet. This is an extension to the cloudlet which stores all the information encapsulated in a cloudlet. Along with all the information, it also stores the ID of a virtual machine that is running it. The next class is the cloudlet scheduler class. This is an abstract class that represents the policy of scheduling performed by the virtual machine. This class is extended by three other classes, which is your dynamic workload, space chat, and time chat. These classes implement the policy for scheduling performed by the virtual machine. The next class is your const class, which stores all the constants defined within the CloudSim. The data center class is a cloud resource whose hostlets are virtualized, and this class deals with processing of virtual machine queries. Moving on to the next class, which is your data center broker class. It acts as a broker on behalf of the user, and it hides the virtual machine management as the virtual machine creation, submission of cloudlets to the virtual machine, and destruction of the virtual machine. The next class we encounter is your data center characteristics class. This represents a static properties of resource such as the resource architecture, operating system, management policy, cost, and the time zone at which the resource is allocated along the resource configuration. The next class is your data cloud tag. This class contains additional tags for data cloud functionalities such as the file information retrieval, file transfers, and storage information. Next class is our file class. The file class represents a physical file in a data cloud environment, whereas your file attribute class it's a class used for storing the related information regarding an entity.
The next class we encounter is your hard drive storage class. It's an extension to the storage class. This is an interface which defines the desired functionality of a storage system in a data cloud. This class is being extended by the SAN storage class and the hard drive storage class. The hard drive storage class basically is used to simulate the behavior of a typical hard drive storage, whereas your SAN storage class represents a storage area network which is composed by a set of hard disks connected in a LAN. The next class is the host. This executes all the actions which are related to the management of a virtual machine, whereas the host dynamic workload class is used to support a dynamic workload and performance degradation. The host state history entry is this class is basically used in order to store the state of the host, and we have the info packet. This class is used in order to gather the information from the network layer. The information can be something like the bandwidth or the round trip time, etc. Then we have the log class. This is used for performing login of simulation process. The next classes, which is the network topology and packet classes, these classes are used when there is a need to implement a network layer in a CloudSim. The next class, which is your parametric exception, is used to report a bad or an invalid parameters given during constructor. Moving on to the next class, which is your processing element class, is used to represent a CPU unit which is defined in terms of million instructions per second rating. The next class, which is your RES cloudlet class, is represent a cloudlet submitted to a cloud resource for processing. It basically contains a cloudlet object which has the information like the arrival time, the ID of the machine, or the processing elements which is allocated to it. The next class, which is your utilization model class, it is an interface and consists of three variations, which is your full, null, planet, lab in memory. These classes are used to implement a control over the resources used by the cloudlet. The next class is your VM class, is used to represent a virtual machine which runs inside a host. Moving on to the next class, which is your virtual machine allocation policy. This is an abstract class and is extended by the virtual machine allocation policy simple. This class represents the provisioning policy of hosts to virtual machines in a data center. The next class, which is your virtual machine scheduler, is an abstract class that represents the policy used by a virtual machine monitor to share processing power among virtual machines running in a host. This class is being extended by three other classes, which is your space shared class, time shared class, and time shared over subscription class. Next class is your VM state history entry, which maintains the state of a virtual machine. Moving on to our next package, we have is your CloudBus CloudSim code. This package contains all the main classes of this project. The classes within this project is responsible for initiating, starting, maintaining, and ending the simulation process. The first class within this project, which is your Cloud Information Service, is an entity that provides cloud resource registration and indexing and discovery services. That is like when a host is ready to execute a cloudlet, then it has to register with this class. Or if a resource broker requires a list of resource IDs available, it has to get these information from this class. The next class within this package is your CloudSim class, which is used to enable the network simulation in CloudSim. This class is also used to disable all the network models from CloudSim to provide a simpler simulation of the network. The next class is the CloudSim shutdown, which waits for the termination of all the CloudSim user entities to determine the end of the simulation. The CloudSim tag class contains various static command tags that include a type of action that need to be undertaken by a CloudSim entity when they receive or send events. For example, we can see here is your register resource event, which is also being provided with a unique identifier. This class basically lists all the events that a CloudSim encounters. Next we have is a deferred and future queue classes. This provides a list implementation of the queue in order to store the events used by the simulation. The sim entity class represents a simulation entity, that is, it holds the behavior of the entity, whereas a sim event class represents a simulation event which is being passed between the entities in simulation. The next package we have is the predicates package, where we have classes that are responsible for selecting matching events from the deferred queue class for executing the event on a specific entity during the simulation process. Now this consists of a predicate class, which is an abstract class and is extended by all these other classes. Predicate any class will select any event from the deferred queue, whereas the predicate none class will not match any event from the deferred queue. We have a predicate from class which will select events from the specific entity, whereas a not from class will select events that have not been sent by a specific entity. We have the not type and type predicate classes, where not type will select the events that don't match specific tags, and type class will select events with specific tags. The next we have is our distribution package, which consists of these many classes. Now the classes within this package have a predefined network traffic distribution method implemented in it. For example, we have a continuous distribution or an exponential distribution, a gamma distribution, we have logarithmic distribution, a uniform distribution. Now whenever in our project we require to execute a network distribution, we can use the classes which are specified in this package. The next package which we have is our CloudSim list package, which has a number of classes that implements the predefined operations related to the component list during simulation. For example, the cloudlet list, it maintains a list of all the cloudlets that has to be processed by the virtual machines. The host list maintains a list of all the hosts, whereas the PE list maintains a list of all the processing elements that have been assigned, that is your CPU units that has been used by each virtual machines. And then we have the RES cloudlet list, which maintains the cloudlet that have been already submitted to the cloud resource for processing, and then your VM list maintains a list of all the virtual machines. The next package we have is a network package. Network package consists of classes that produce a behavior which is related to the network packet routing. For example, if we take the Floyd-Warshall algorithm which is provided by one of the class, it is used to calculate all pair of delays and predecessor matrix. Similarly, all the other classes, they provide one or other network routing technique which can be used directly in our project. The next package which we are going to see is the network data center package. The classes within this package produce simulation behavior for geographically distributed data center of cloud service providers. These classes is an extension to the classes which is available in the or CloudBus CloudSim package. These package add certain network specific features to the base class. The next package or packages, that is your power list and power model package. In these packages, the classes within the or CloudBus CloudSim are extended to produce behavior for power aware components. These packages can be used to implement green computing related work. The next package which we encounter is the provisioners package. The classes within this package is used during the allocation of a bandwidth or processing element or RAM to the virtual machines that executes the cloudlet. Here we have three base classes, which is your bandwidth provisioner, PE provisioner and RAM provisioner, which is extended by their respective simple classes. The next package is the util package. Basically, this consists of classes which measures the execution time and perform certain basic mathematical operations which is required by the CloudSim. To summarize all the classes which we have seen till now, here is the class diagram for the CloudSim simulator, where we can see the relationship between each classes, whether it's a one-to-one relationship or a one-to-n relationship. We can also see how the classes, how the derived class extends the base class and the abstractions between different classes. Hereby we end the brief description of all the packages within CloudSim.
Hello, I'm Sheetal. We'll now see how simulation runs in CloudSim by taking an example from the example package which is provided in CloudSim. Before we go to Eclipse and see which are the set of codes and methods that are executed during simulation, we'll see certain important classes that we come across during simulation. The first important class is CloudSim.java. This class contains the basic and the most important functions that are called during the simulation, and it acts as an intermediate between all the different class calls. Those classes can be SimEntity.java, SimEvent.java, deferred queue, future queue, data center broker. These entities are extended from SimEntity. And these are the main classes which we encounter during simulation. So the simulation starts with the start simulation method, which is present in CloudSim.java, and the general scenario that happens during simulation is a two-phase process. In phase 1, events are generated and these events are added to the future queue. In phase 2, the events in future queue are moved to the deferred queue. These two queues are used in CloudSim to allow dynamism to the CloudSim environment. In a dynamic environment, new components are generated in runtime. So in order to maintain the list of these new components, we use the future queue. Once all the new components are added to the future queue, they are moved to the deferred queue in a sequence. And the events in the deferred queue will be processed in actual. Let us now go to Eclipse and see how the simulation actually happens. To show how the simulation flow goes, I'll take a very simple example which is provided in this package org.cloudburst.cloudsim.examples. Since this example is the simplest of all the examples here, I have taken this one to demonstrate how the simulation goes on. We'll start our simulation with this particular line of code. CloudSim.start simulation. This particular method call actually allows the simulation to begin. So let us now start debugging the code. So it's asking me if I want to open the debug perspective. I'll say yes. So here we are in debug perspective now. The debugging starts from this particular line of code. We have two options here. One is step into and the other one is step over. Step into is used when we want to get inside the method call, and step over is used when we just want to execute the method and we don't want to get into the code of it. So here I'm going to step into. So now we are in start simulation method. which is present in CloudSim.java. Here it first prints the starting CloudSim version, the version number of the particular CloudSim which we are using right now, and it now makes a call to the run function. So we'll now get into this particular function. Okay. So we now came to the run function, which is again present in CloudSim.java. Now it checks if the simulation is running. Since it is false, it now starts all the entities by making a call, run start. We'll now jump to that particular function. Okay. The run start function is again in CloudSim.java. Now the running flag is set to true. Here now we see the entities which are created when we made a call to CloudSim.init function. We have 4 entities here. Okay, the CloudSim shutdown, which is given a unique identity 0, cloud information service with unique number 1, data center 2, and data center broker 3. Whenever we use these entities as either source or destination, we use their unique IDs, that is the 0, 1, 2, and 3, instead of using their names. This particular set of code calls the start entity method of each of the entity present in entities array list. So let us now go see the entities. Okay, the first entity is being the cloud shutdown. Okay, start entity. Since the cloud shutdown extends SIM entity, SIM entity has start entity, which is an abstract method, so it has to be implemented here as well. Let us continue. Okay. The second entity is the cloud information service, which again extends SIM entity. The start entity of this is implemented again. We'll next see the third entity is data center. This start entity method has some set of code here, which says that particular entity is starting. Okay, it will now go to the get name function in sim entity, and it will return name, which is the data center 0. Okay, this particular line of code is printed. Data center 0 is starting, is printed now. So we have to register the data center to the CIS. So we have to first fetch the CIS entity identity. Okay, let us now go through the code. Okay, it gets the uh, ID of the CIS. We'll see. Gets the entity ID of the CIS. We now came back to get cloud info service entity ID, which is in CloudSim.java. and it returns the CIS ID, which is 1 here. So GIS ID now holds the entity ID 1. Now one important function is being called now, which is send now function, which is present in CloudSim SIM entity. Uh, it passes three parameters: GIS ID, which is 1, which is the ID of the cloud information service, and this is the ID of the data center. As we had seen before, each of the entities were given a particular ID. CloudSim shutdown entity had the ID 0, CIS 1, data center had the ID 2, and the broker had the ID 3. Mm, this function is being called here for registering uh, data center to the CIS. Let us get into this function. Okay. We are now in send now method of simEntity.java, which has taken the entity ID, which is 1, sim tag, which is resource registration, and we have a um, object data whose value is 2, that is the entity which is data center, and it makes a call to the send function. We'll now go there. This function takes 4 parameters: entity ID, which is 1, certain delay, no delay given here, the tag, and the data of object type, which has the value 2. Here we made certain checks. We checked that the entity ID shouldn't be less than 0, because if there's no destination entity, that particular event will not be processed. We then check the time, and we then get the source ID here. So now we have all the 4 things. We calculate the delay. If we are working on networks. Now the schedule method from the same sim entity class is called, which takes the parameters sim entity ID, the delay, the CloudSim tag, and the data. So now we are in the schedule method of sim entity. Here it makes a call to the send method of CloudSim, which takes 4 parameters: the source ID, the destination ID, the delay, the tag, and the data. Here the source ID is 2, the destination ID is 1, delay is no delay, tag is 2. To see what tag the number 2 corresponds to, we'll have to go to the CloudSim tag class. Here the base is 0, and register resource has the tag with number 2. So is data center, and the destination ID is 1, which is CIS, and the tag is resource register. So the data center is registering itself to the CIS for the resources it has. Let us now get into the details of send method of CloudSim. Here it first checks if the delay is less than 0. So if the delay is less than 0, it throws an exception. Next, we are generating an event. If we check the constructor of sim event, we have 5 parameters in that: the event type, the delay, the source. If we see the constructor of sim event, it asks for 5 parameters: the event type, delay, source ID, destination ID, tag, and an object. We have passed all these parameters in the previous call. So now we have an event generated here with the event type send. The event generated has the following details. It has the data, it has the delay, destination ID which is 1, source ID which is 2, event type, and all the other details it needs. Okay. We'll now see how it is added to the future queue. Let us get into the details of it. If we see here, we have add event function in the future queue class. We add 1 to the serial number and event to the future queue. So this is how the event is scheduled here. Okay. So now we have registered the data center with the CIS. We now have to generate one more event, which is fetching of the data center characteristics. Let us now see how that happens. Okay, the fourth entity that was to be generated is the data center broker. We'll see how the event is scheduled for the broker. Uh, the the schedule gets the destination ID from the sim entity class, and it specifies the delay, and the tag is resource characteristics request. Let us now get into that. Okay. We now call the schedule method of the sim entity class, which has the destination ID, the delay. If we see here, the destination ID is 3, which is broker again. So here we have both the source ID and the destination ID the same, which is ID 3, which corresponds to the data center broker. So this event occurs between two brokers, and the tag uh, corresponding to 15 is, we'll see now. So resource characteristic request has the tag with 15. Okay, let us now go back. Okay, this further calls the schedule method of the sim entity with the. Let us now go to that. It checks if the CloudSim simulation is running. Yes, it is. So now it calls the send method of the CloudSim class. It checks if the delay is negative. It throws an exception if the delay is negative. So again, an event is generated, which the event is again sent. The delay, source ID, destination ID, tag, and the data is specified. So we now have an event generated here with the data, no data, and the waiting time is 0. Destination ID, source ID are both 3, which corresponds to the data center, and event type is 1 here. Serial number -1. The event tag is 15, which corresponds to data center characteristics request, and the delay is 0. So we now add this event generated to the future queue. Um, we add we now add 2 to the serial number because we already have one event which is register resource already in the queue, which had the serial number 1. So this particular event has the serial number 2, and now it is added to the future queue. So this is how we schedule the second event as well. So this is how we generate events and add them to the future queue. So now we are done with the phase 1 of the simulation, which is generation of events and adding them to the future queue. We'll now go to the phase 2. So all the entities are started now. We'll go back to the run method. Here we have an infinite loop. As long as we add events to the future queue, or there are any events in the future queue, this loop will be executing. So once all the events are done in the future queue, this loop will be terminated. So till now we have 2 events in our future queue and we have nothing in our deferred queue. The process starts with checking in the deferred queue if there are any events, and if there are no events, it will go to the future queue and move the events to the deferred queue. We have this run clock tick method, which is the most important method in the simulation. This is the method which sends call to the processing of events in the deferred queue, and it also makes calls for processing and moving the events from future queue to deferred queue. So let us now go into details of run clock tick method. Um, in this method, we have this set of code which is again calling the run method for each of the entities present in the entities array list. Once we are done with this set of code, we'll move to this part of the code where the size of the future queue is checked, and we call the process event to further move the events from the future queue to the deferred queue. Let us now see how all that happens in detail. If we see the size of the um, entities, it is 4, so we have 4 entities. So this loop goes on for 4 times. Let us see how that happens. Okay. It will check if it is runnable. Only if the entity is runnable, it will execute the run method. We'll see what happens now. It will fetch the state. now we'll see what happens in the run method. So once we are in the run method of sim entity class, we'll first check if there are any events available for any next event available for that particular entity. If there are any next events, we'll process that event by passing that event to the process event method of sim entity class. Let's go and see what exactly is there in the get next event method. In the get next event method, which is there in the sim entity class, um, it again makes a call to the get next event with the parameters cloudsim dot sim any. This is a predicate which always returns true. Let's go see what is there in the get next event method. Here we are again making a call to the num events waiting method, which checks if there are any events which are already waiting in the deferred queue, and if there are any, we have to process them. Let us see that. It's checking. It first checks if the CloudSim is simulation is running. Yes, it is. So it will now check if there are any events in the deferred queue waiting to be processed. We can do that using the waiting method of the CloudSim. Since there are no events available for the first entity, it returns null. Okay. We'll just pass through these particular set of code now. I'm just passing through that. We'll see it in the next phase in detail. Next, we are in the future phase where it checks the size of the future queue. Here it is 2. We'll see that. The size of the future queue is 2, which means there are 2 events in the future queue. Here we move the events from future queue to the deferred queue. For that we start with an iterator. It chooses events from the future queue to be moved to the deferred queue. It uses the process event method to move the events from future queue to the deferred queue. So let's see how it happens. Let's get into the details of process event. So the event to be processed has the following details. Its destination ID is 1, which corresponds to the CIS, and the source entity ID is 2, which corresponds to the data center. The event type is 1, and the tag is 2. Okay. Here we perform certain checks. It will check if the event time is less than the clock time. Then it means that the event has already happened. It will then fetch the time and check what type of event it is. It recognizes the event to be send event. It now fetches the destination and checks if the destination is less than 0. If it is, it means the null entity is detected. Otherwise, it will fetch the tag. The tag should be 2 here, which corresponds to the event of resource registration, and the destination entity is we'll see now is the cloud information service. whose ID is 1. Now we'll check if the uh, state of the entity is waiting. If it is, we are doing nothing, but we are just adding predicates. Because this entity CIS is already running, we do not go to this part of the code. We'll directly execute this part of the code, adding this particular event E to the deferred queue. So once we are done with adding event to the deferred queue, we'll go back to the run clock tick method, and we are going to remove the previous event from the future queue. So in this way we reduce the size of the future queue. So if we see the size of the future queue now, it will be 1. This is because we have removed the event from the future queue and added it to the default queue. Next, we again check if there are any more events in the future queue. If there are any, we'll have to process them. Okay. So now the event will be processed. Let's see the process event now. Here again it will check the event time, and then it will fetch the time. It will then find the type of the event. Uh, it's again the send event. It will fetch the destination ID. Uh, it will check if the destination is the null entity, otherwise it will fetch the tag. This time the tag is 15, which represents the event of data center characteristic request, and the destination is 3, which corresponds to the data center. So the destination entity is the data center broker here. We'll see if the state of the destination entity is waiting. Since the data center broker is running, we'll add this particular event of getting the resource information, that is data center characteristics, to the deferred queue. So this is how we move the events from future queue to the deferred queue. So this is how it is done. So now if we see, the deferred queue has a size of 2, whereas once we remove the events from the future queue, its size will be 0, because both the events which were in the future queue are now moved to the deferred queue. So now we are back to the run clock tick method. So next time when we execute this set of code, will be processing the events in the deferred queue. So let us finish this part of it. It checks the termination time and the clock. This iteration is over, so now we come to the next iteration of this while loop. Here we fetch the entity size. So now the entity is the CloudSim shutdown entity. So we run the run method for that. Since there are no events for this particular entity, it will return null. So we execute the run method for the next entity now, which is the cloud information service. we'll see the details of it. It will now see if there are any next events for this particular entity. Uh, it will get the next event from the get next event method of the sim entity. Uh, it will go to the get next event method. Uh, it will call the num events waiting method. It will execute the waiting method of the CloudSim class. So the waiting method is passed with the destination ID and the predicator. We here have a iterator for the deferred queue. We'll check if there is anything in the deferred queue. If we see the deferred queue, it has the size 2 here. We'll fetch the event to the this variable event. Okay, if we now see this, it has the destination ID 1, the source ID is 2, and the event type is 1, the tag is 2. Here the source is the data center and the destination is the cloud information service center. We'll now check for the match here with the destination ID passed and the destination ID of this particular event. Let's see that gets the destination ID which is 1, so there is a match, and will increase the count. Will now increase the count, so now the count is 1. So we'll see for the next event. It will now see the destination ID of the next event with the ID passed. If we see here, the destination ID is changed to 3, which corresponds to data center broker, so there is no match, hence the count doesn't change. So the count is still 1. We'll see with the next iteration. uh, so the final count is 1. So since we had only 2 events, the while loop looped for 2 times and returned the count. There's only one match for this particular destination, so the count is 1 now. So when we go back and we get the value of this particular um, num event waiting to be now it has the value 1 and it is always greater than 0, so we'll select that particular event now. So the select event further calls the select method of the CloudSim with the ID 1 and predicate value. So we are going to call the select method. Here again we have a deferred iterator. Here this iterator checks if the event which we are trying to select has the same source. Now we remove the event from the iterator. The size of the deferred queue is 2, and after executing this particular line, the size of the deferred queue will become 1. So now we have removed an event from the deferred queue, but it will be cached. So the cached event is now returned. Okay, which is further returned to the sim event here. So now if we see, we have the same event uh, okay, with the destination ID 1, source ID 2, and the event tag 2. In this way we fetch the event with the destination ID 1. So once we have the the event to be processed, so we have to now process the event. We'll now go processing the event here. This process event, which is implemented in cloud information service, now it now fetches the tag of that particular event. So the tag has to be 2. Okay, uh, now now it finds the match here with the resource register. We'll see that yes, uh, the match is with this. Now this particular instruction is executed. Here we add the ID of the data center to this particular list. So this means we have registered our data center with the cloud information service. In this way we do the registration process. So next we'll see if there is any event available for this particular entity. If there is, we'll have to process that event. Since there is only one event for this particular entity CIS, we'll exit this part of the code. So if we now see this, uh, there's no more events, so we'll exit this while loop now, and our uh, call goes back to run clock tick method. We'll now be running this for loop for the next entity. We'll see we'll check the state of that particular entity. If it's runnable, we'll execute the code. Now the entity is the data center. We'll see what happens in the run method. Since we have no event corresponding to the data center entity, it will return null. We'll just see that, and the count will be not greater than 0. We'll just check that. Okay. If we now see the it's returning null. So we have no event available, and the event will be null here. Since there is no event, this part of the code is not executed, and we return to the run clock tick method. We now process the run method for the next entity. So the next entity is the data center broker. As we know, there's one event left for the data center broker, that is the fetching of the data center characteristics. We'll see the what happens in the run method for this particular entity. It will see if there is any event for this particular entity. It will go to the num events waiting, and then to the waiting method of the CloudSim. If there is any event corresponding to the destination ID of 3, the count will increment to 1. It's now fetching the destination. Yes, the destination ID is 3 and the ID passed is also 3, so there is a match, and now the count should be incrementing. So we now have the count equals 1, so which means there is one event corresponding to the ID 3, which is the data center broker. Now we come back to the num events waiting. So here the count will be 1, which is greater than 0. So we will be selecting that particular event. What we doing here is fetching the event from the deferred queue and removing the events from the deferred queue so that we can process that particular event. Here we'll fetch the event and try to match it with the destination, uh, sorry, the source. So here the id is 3 and our source id was also 3, so there's a match. And now we are removing the event from the iterator. Okay, we are returned, and this event will be in the cache. We'll return it to the uh, process event method. Here we'll process this event. If we see, the event has the destination id 3, the source id 3, the event type is 1, and the tag is 15, and the tag is 15 here. Since the event is not null, we'll make a call to the process event for this particular event. We'll see that now. In the process event method of data center broker, the event tag is fetched. So now the tag should be 15, which corresponds to data center characteristics. Let us see that now. So now it switches to that particular case, resource characteristics, data center resource characteristics request, and now it will process this particular instruction. So we'll now see the call to this particular method. Here it needs to schedule one more event. In this method, if we see, for each of the data center, one more event is being scheduled here, and the send now event will add, we'll get back to that. The send now event will add one more event to the future queue. We'll see that. Okay, the send now, which makes a call to the send method of the sim entity. Here the id is 2, the CloudSim tag is 6, and the object carries the value 3. In this way, the events are scheduled in between. In the send method of sim entity class, we make certain checks, as we saw in the earlier part. We'll just pass through those. It will calculate the delay if it is related to the networking part. So now it will call the schedule method. We'll see that. It will check if the CloudSim simulation is running. Yes, if it is, it will send. It will now make a call to the send method of the CloudSim. The ID is 3. The destination is 2. Delay, no delay. Tag is 6, and the data with value 3. We'll now go there. Here is where we actually generate an event and add it to the future queue. So this event has the destination ID 2, the source ID is 3, event type is 1, and the tag is 6. Now the event is being added to the future queue, and we return. So now we have added event now we are back to the run method here. So now we'll find if there are any more events available. We'll see if there are any events available. If it is, the count will get incremented. So since there are no events, the count is 0. So there are no more events for that particular entity. So the event will be null, and hence this part of the code is not executed. We are now back to the run clock tick method of CloudSim.java. So the same thing goes on as we did earlier. So we have the future size to be 3. We have added the previous two events are already moved to the deferred queue and processed. Now we have added one more event to the future queue. So we'll have to move it to the deferred queue and process it. So we'll be doing that part now. So the same process goes on as we seen earlier. It will fetch the type of the event, and which is again send. It will find the destination. So the destination here will be corresponding to the tag 2. The same process goes on. So now the event is added to the default queue. So we'll now remove the event from the future queue, and now it again checks if there are any more events for that particular entity. If there are any, we'll have to process them. So now the entity is all removed from the future queue. So in this way we scheduled one more event in the second iteration of the run clock tick method. Here again we make certain checks. These two conditions will be checked when we are ending the simulation, when we are at the end of the simulation, and this particular part of the code is executed when we are explicitly terminating the simulation. We now go again to run clock tick method. Okay, these checks will be done, and again we are to the run clock tick method of the next iteration. Here we'll call the run method for the entities. So if we see the size of the entity, it is 4, and the same process repeats for each of the entities whichever are there in the entity array list. We'll now go to the run method of it. Here it will fetch if there is any event for that particular entity. If there is no event, it will return null. So if there is any event, it will increment the count to 1. Let us see. So since there is no event, the count is remained 0. It will return null here. Null. We'll go back here, and there's no event here, so this part of the code is not executed. We'll be skipping it. We'll come back, yeah, and we'll see for the next event, next entity. Okay, now the entity is CIS
it will again check if there is any event for that particular entity. If there is any event, it will increment the count. So there's no event for even this. It will return null. We'll skip that part. We'll go back. We'll see for the next entity. So the next entity being data center. We'll see if there is any event for this particular entity. The same process repeats. So the count is now incremented, which means there is an event for the data center. So now the count is 1. It will return 1, which is always greater than 0. So the event is selected for being processed. Now we are checking, this part is already explained. So the deferred queue has an iterator, and it checks if the destination of the event required matches with the mentioned source here. It will, if there is a match, then that particular event is removed from the iterator and put it in the cache so that it can be processed. So now we have the event here. We'll go back, and here we have the event. We'll see which event is that. So the destination entity is 2, the source entity ID is 1, the tag is 6. This is the event which we added lately. So now we'll have to process this event. We'll see the processing of this event. The same process repeats for this event as well. It will fetch the tag and corresponding case will be executed. We'll see that. So it will fetch the tag. The tag corresponds to the resource characteristics. Since the resource characteristic in communication is a two-way communication, this event is being happened twice here. So now we are adding the data center to the CIS. I mean, we are communicating the resource characteristics between the data centers. So now the send now is again called. We'll see. It will take the source stack to be 3, which is the data center broker. Okay, it will fetch the characteristics. It will again come to the send method. It will check for some of the things here, and again it will schedule an event. So this is how we schedule events and add them to the future queue and move them to the deferred queue. This process goes on and on as long as we have events in the future queue and we move them to the deferred queue. I'll now move on further. So the certain checks are made here. So the event is scheduled. The same process repeats the number of times we have the events for the respective entities, and we'll Okay, so we are now seeing some results in the console here. Okay, we are now finishing the simulation, as the simulation says there are no more future events, which means the simulation would end now. So okay, the termination is being happened now. So now there are no more events, so simulation will finally end. So now we saw the entire simulation process. In the next video, we'll be seeing um, a detailed explanation of an example, and then you'll be clear about the output given here. I'll just show the output, what will come here. So this is how the output looks like. Uh, the details of the output part will be explained in the next section. Thank you.
Hi, I'm Vasama. In this part of the video, we are going to discuss about the basic steps that every example of the package org.cloudbus.cloudsim.examples implements.
Hello, in this part of the video, we are going to discuss about the basic steps that every example of package org.cloudbus.cloudsim.examples implement. This is the first step for understanding the basic working of CloudSim simulation framework and how we can implement our own research application on this simulation framework. To understand this particular framework code, we need at least intermediate level of Java language understanding. Let's start now. Every simulation example follow these steps, and these steps are in sequence. The first one is we need to set the number of users, and this correlates with the broker count. The next is initialization of common variables, and the common variables may be set of virtual machine lists or the cloudless lists, etc. Next is that object of the CIS is created. The data center is created. Creation of data center will also create host plus the characteristics, and the characteristics can be RAM, processing elements, and the bandwidth utilization, etc. Later, this data center is registered with the CIS when we start simulation. The fifth step is creation of the data center broker instance. The data center broker deals with the communication between the data center and the submission of the cloudlets and VMs. The next step is virtual machine instance creation. Virtual machines have the same characteristics as the data center but on the lower level. Once the VMs are created, these VMs are submitted to the broker. Next step is specifying the cloudlets, and the cloudlets are created with the parameters such as MIPS requirements, bandwidth requirements, etc. And next, once the cloudlets are created, these cloudlets are submitted to the broker. Now the broker has both VMs and cloudlets, and the cloudlets are mapped to the VMs by the broker. Till now, we were only preparing for the simulation by creating the data center, virtual machines, cloudlets, and initializing those common variables, etc. Now we will start the actual simulation. Once the simulation is completed, we will stop the simulation process and then print the status of the simulation. Let's come back to the code now. This particular example has the package name org.cloudbus.cloudsim.examples, and the list of import statements. And these import classes are basic Java classes, and these are the CloudSim classes. And this example uses cloudlet scheduler, timeshare, data center broker, data center data center characteristics, host, and the log to be printed, processing elements, storage, utilization model, full virtual machine allocation policy, simple virtual scheduler, time shared, which is used by the virtual machines, and the provisioners, or that is bandwidth provisioner, simple, and the processing element provisioner, simple, and the RAM provisioner, simple, etc. This example shows how to create a data center with one host and run one cloudlet on it. And the class is the CloudSim example 1. And this class has two private static variables, that is cloudlet list and the VM list. And the cloudlet list maintains the number of cloudlets that are submitted in this example, and the VM list maintains the number of VMs that are submitted to this example. When we look at the structure of this example, there are 4 methods defined. Those are create broker, create data center, main, and the print cloudlet list. And the main method is the first one to be started. So we'll start with the main method and look at the other methods when they are called. In the main method, we can see the particular message that is starting CloudSim example 1 is printed. And this main method, it also initializes the number of users, calendar, and the trace flag, which is a boolean variable, and this trace flag variable keeps track of the events. And this main method, it calls the init method, where these variables are passed on, that is number of users, calendar, and trace flag. When we look at the declaration of the init method, this method, in this method the number of user, calendar, and boolean variable, that trace flag, are passed, and this init method in turn calls the init common variable. And this init common variable method is defined in cloudsim.java, and here trace flag, calendar, and the CloudSim shutdown object are initialized. When we come back to the init method, the Cloud Information Service object is created with the name Cloud Information Service, and the ID of that CIS is extracted. Now the Cloud Information Service and the Cloud Shutdown, these two are the entities. Now till now, with this init method we have initialized everything. Now once this is done, we need to create the data center. So when we go into the declaration of this data center, and it is previously said that with the data center the hosts are also created. So here we can see the list of hosts are also created, and the processing elements that are required by these hosts are also created and put it in the list. And this is the MIPS, that is the processing capacity for the host is also initialized, and these processing elements, they are added to this PE list. Once the processing element list is defined, we need to house this list in a host. So to define the host, we need the characteristics of host. So host ID, RAM, storage, and bandwidth are the characteristics of the host. Once the characteristics are defined, we need to add this host to the host list with those characteristics. Once the host list is ready, we can create the data center. To create the data center, first we need to define the characteristics of data center. This is only for the sake of information. We are defining the architecture of the system, operating system, virtual machine monitor, etc. Here we are defining the characteristics of the data center, that is time zone, cost per bandwidth, cost per storage, cost per bandwidth, cost per memory, etc. Once these characteristics are defined, we need to set the characteristics. So here with these characteristics we are setting the data center characteristics with those previously defined characteristics, that is cost per bandwidth, cost per storage, host list, etc. Once the characteristics are ready, we can create the data center with the name, characteristics, VM allocation policy, storage list, etc. Once the data center is created, it is returned back to the main method in the variable data center 0. Now we have created the data center. Next we need to create the data center broker. Here we are creating the data center broker with the create broker method. When we go into the declaration of this method, here they are creating the broker with the name broker, and then that is returned back to the main method. Once we have created the broker, we are extracting the ID of that broker. Once the data center and the data center broker are created, next we need to create the virtual machines. To create the virtual machines, so we have some of the parameters for those virtual machines, that is virtual machine ID, capacity, that is MIPS, and then the size, and then the memory of that virtual machine, bandwidth, and then the processing element number, etc. Once we have defined the parameters, we can create the virtual machine with the new VM method using these parameters. Once the VM is created, it is added to the virtual machine list, and then these virtual machines are submitted to the broker. Once the virtual machine is created, we next will create the cloudlets. That is, the cloudlets have some of the properties such as its ID, length, file size, output size, and then the utilization model. And once the properties are defined, we'll create the new cloudlet with these parameters, and then we'll extract the broker ID of that cloudlet and the virtual machine ID of that cloudlet, and then we'll add that cloudlet to the cloudlet list. Once the cloudlet is added, we'll submit all the cloudlets to the broker. Till now we were only preparing for the simulation, that is by creating and initializing all those parameters of the broker, data center, virtual machines, etc. Now the actual simulation starts here when we call the start simulation method. Once the simulation is completed, we'll call the stop simulation method, where all the entities are shut down, such as CIS, broker, data center, etc. And finally we'll print the status of this example. And once we have completed the simulation of this, so we'll print the status of that example. Now here we'll show how to run this example. So when I run the example, here we can see the output. See, this is starting CloudSim example, and it is initializing all the common variables, and the version of the CloudSim is 3.0, and since we are creating only one data center, here data center 0 is the name of the data center, and broker is starting, and all the entities are started now. And now the cloud resource list too, that it is received with one resource, and it is trying to create one virtual machine on this data center 0, and this virtual machine has been created in this data center 2 on this host 0, and now sending the cloudlet 0 to virtual machine 0. Now this 0 is the ID of the cloudlet, and now this cloudlet 0 is received, and all the cloudlets are executed. Once the cloudlets are executed or finished their tasks, it will destroy the VM that is virtual machine, and broker is shutting down. So when we call the stop simulation method, all the entities will be shut down, and now simulation is stopped since there are no future or no more events to execute. And finally all entities are shut down, and data center is shutting down, the broker, and simulation is completed. And this is the output, that is the ID of the cloudlet is 0 and the status is success, that is the execution, the cloudlet is completely executed on this data center, that is data center 2, on this virtual machine with the ID 0, and it took the time 400 unit of time to complete that task. So its start time is 0.1 and its finish time is 400.1. So finally it says that CloudSim example is completely finished.